location of center of gravity. This is needed when you are trying to calculate moment of inertia of an unsymmetrical section whose center of gravity is not known. Okay, center of gravity మనకి ఎక్కడ ఉంది అని తెలియకపోతే you cannot calculate the moment of inertia of this unsymmetrical I section. So you need to first find out what is the location of that, and from that we will calculate moment of inertia also. So in this short video, let me explain you how we calculate center of gravity. Okay, so now as shown in this figure, this is the section, this is a section, okay, I section, which is unsymmetrical. You can see that the top and bottom flanges are of different dimensions, isn't it right? Therefore the center of gravity will not be at the exact center of the I section. It is somewhat going to be towards the lower flange. Okay, it is going to shift towards this larger flange. So let us find out what is the exact location, okay, of the center of gravity of the I section. So let me just assume that the center of gravity is at this particular point, and let me take that the location of that center of gravity is something like y distance from the bottom. So here the unknown is the y, isn't it right? We do not know what is the location of center of gravity of the I section. So let me write this as CG, center of gravity, which is at a distance of y from bottom. You can also take the location from the topmost layer also. Okay, so now this is CG, and so in order to find out the location, let us divide this complete I section into 3 parts. Okay, top flange is 1, this web is 2, and this is 3. So you know these two are flanges, and this is web. I section, if you consider them as individual, they are going to have certain area, and also they are going to have their own center of gravity, CG1. And similarly, this web is also going to have its own area and center of gravity, CG2. And this lower flange 3 is also going to have its CG somewhere, CG3, and it has certain area. So let us consider the area as A1, and the area of the web is A2, and lower flange is A3. So now let us consider that. Let me consider this C. Right. So let the center of gravity of the first flange is at a distance of y1 from the bottommost layer, and the center of gravity CG2 of the web is at a distance of y2, and the center of gravity of the lower flange is at a distance of y3 from the bottommost layer. So this is the bottommost layer, if you are thinking what is it. bottommost layer. So that is the bottommost layer. So see here now, let capital A is equals to total area of I section. Then what would be the value of A? So you know the A1 is the upper flange area plus A2, it is the area of web plus A3, it is the area of the lower flange. Isn't it right? So now, so now, what is the moment of area? Okay, what is the moment of area about the neutral, bottommost layer? Okay, let's calculate. Let's calculate moment of area about bottommost layer of all the parts. So what would it be? So if you say that, if you consider the first flange, what is its area? A1, and it is at a distance of y1 from the bottommost layer, right? Centroid, from the centroid you have to consider that. So this is the bottommost layer about which you are calculating the moment of area. So area into perpendicular distance. What is the area of the flange? A1, and it is at a distance of y1. So A1, y1. And what is the moment of area of web? A2, y2. And what is the moment of area of third part? A3, y3. So if you add all these three, what do you get? It is the moment of area of the all the parts about the bottommost layer. Let's take this as total moment of area. Okay, total moment of area. So this is the total moment of area. But in the same way, I can calculate the moment of area in a different way manner. See, so we also have that total moment of area is equals to A into Y. Isn't it right? So we can also find out the total moment of area in another way. What is that? If you consider this I section completely as a single part, if capital A is the area and if y is the distance between the center of gravity of that area to the bottommost layer, so total area of the I section multiplied by distance between the axis under consideration to the center of gravity y will give the moment of area of this complete I section. Isn't it right? So this and this both are same. If you consider this as equation 1 and if you consider this equation 2, 1 is equals to 2. 1 is equals to 2. So what can you write? What can you write? So we can say that A y is equals to A1 y1 plus A2 y2 plus A3 y3. Isn't it right? So what is y? A1 y1 plus A2 y2 plus A3 Y3 divided by A. Isn't it right? What is A? A1 plus A2 plus A3. So this is the expression that gives the location of center of gravity of I section. See here. What is Y? What did we say this? What is Y? So Y is the distance between center of gravity of the I section to the bottommost layer. So this Y gives the location of center of gravity with respect to the bottommost layer. For example, if Y is something like 50 mm, what does that mean? This Y is 50 here. So the center of gravity of I section is at a distance of 50 mm from the bottommost layer. So this is how we find the center of gravity of any section, even if it is a T section. If it is a T section, okay, even for a T section, we can calculate the center of gravity.